Question 3. The lengths of 250 leaves of a certain type of plant are measured. Correct to the nearest centimeter. The results are summarized in the table below. Now we are given the class boundaries here without these less than or equal, less than or greater than or equal. So that means to find the class boundaries, we need to subtract or add the 0.5 because they say to the nearest centimeter. So the error bound has to be that one, then divide by 2. Remember, we move a half this way and then a half this way on any number. Okay, so that's why, and remember, if they want us to do the cumulative frequency, we plot cumulative frequency against the class boundaries. Okay, so we need to find the class boundaries. So let me add it here, class boundaries. So in my class boundaries, you get the lower, you divide it, you subtract a 0.5. This one will give us 4.5. Then the upper, you add the 0.5, that is 9.5. Then this one will be 9.5, then 14.5, then 14.5 to 19.5, then 19.5 here to 24.5, 24.5 here to 29.5, then 29.5 here to 39.5. And then here we shall also get the cumulative frequency. So this one is 18, then plus 28, that one gives us 46, then plus 60, that will be 106, then plus 72, that will be 178, then plus 48, that will be 226, and then plus 24, which is 250. Actually, the last cumulative frequency value you get here must be equivalent to the summation of f there. Okay, that is what we are having there. Let me just add a simple table. So that is what we are having there. Then we come to our grid here, and then we draw the cumulative frequency. So here, remember to put the uniform scale. So that is that. And I'm going to use 2020 because if you look at the cumulative frequency, this is 250, then there is 18. If I use 2020, I think that would be better. So I can use this one here, 0. Then here we have 20, then 40, then 60, 80, 100, 120. Remember, your graph must cover 3/4 of the grid. Okay, that is when it can be reasonable. It is 180, this is 200, this is 220, this is 240, then this one here is 250. Then down here, remember we are moving from 4.5. We are supposed to plot cumulative frequencies, so you have to label your graph here, cumulative, then frequency. You have to label your axis. And then down here we have class boundaries, but class boundaries are coming from lengths. So instead of writing class boundaries, you write length in centimeters. Then I can have, let me try to zoom a little bit such that we can see the markings very well. Every after 5. So I have here, I have here, I have here, I have here, here, I have here, 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 then here and there. So that is that. Now here I can actually use, since the first upper class boundary is 9.5, then I can put the 4.5 here, then 9.5, then the next one is 14.5. I'm adding 5. So the scale down here has to be uniform. It's not about the class boundaries. It's a uniform scale, okay? Then 4.5, we shall have now 19.5, then 24.5, 29.5, 34.5, then 39.5, like that. I don't need any others because the last one is 39.5. Now we plot here on the vertical axis one small box. One small box is equivalent to adding 20. So 20, then divide by their 5 small boxes, so which is equivalent to 4 units. Now we want to plot 18 against the 9.5. You plot upper class boundaries, not lower. So 18, if we say 18 divided by 4, this is actually going to give us 4.5. Okay, so 4 small boxes, 1, 2, 3, 4, then 0.5, it has to be in the middle. So that means we are going to have our plot here. Then the next one, I can even put a small circle there. Then 14.5, 14.5 goes with 46. So 46. So 6 divided by 4, you get 1.5. So I will put here. That is that. Then the next one for 19.5, that one will be 106. So 100 is here. We are seeing 100 here. Then 106, then 6 divided by 4, that is 1.5. So I'll come up here. I add on 1.5 small boxes. Then the next one is going to be 178 against 24.5. 178. So 178 is bigger than 160 by 18. So 18 divided by 4, that is 4.5. That means I'll count 4.5. I'll go up here, 4, then 0.5 there. And then the next one is 29.5 against 226. 29.5. 29.5, yes, against 226. So 220 is here. 220 is here. Then remember it is 26, so 6 divided by 4, that is 1.5. So I'll move up here just like that. Then the next one is 39.5 against 250. So which is actually, pardon me here, this one is supposed to be 260. This is 260. Remember, we are adding 2020. So 250 is bigger than 240 by 10. So 10 divided by 4, that is 2.5. So that means I'll add on from here, I add on 2, 1, 2, then 0.5. So it has to be around here. It is actually in the middle of 240 and 260. Then I join these ones to form a smooth curve. So we join, we try to produce a smooth curve. And then the last one, you proceeded to the 0 here. So that is our graph there. Part B, 38% of these leaves are of length k centimeters or more. Use your graph to find an estimate of k. Since we are using the cumulative frequency, if the length here is k, and then this is what we are having here, and then the value that we get here will be, remember these are cumulative frequencies, so it is giving up the sum for all of these that have gotten a value that is less than or equal to this k. Okay, they have counted from the 0 here up to here. Now if they say or more, that is the other part that is remaining. So what you can do is to first subtract off this 38% from 100. So we shall get our k as 100 minus the 38, the other percentage that is remaining. Okay, this one here, then times the summation of f, which was given as 250. So here you are getting the, when we multiply all of this, what do we get? The 60, will that be 62? Yes, 62% of the 250. 62% is the same as 0.62, then times the 250, that one gives us 155. So we have 150 fifth value. Now we go to our cumulative frequency, we look for the cumulative frequency curve, we go to the cumulative frequency axis, then we look for 155, then we draw a line that meets with the curve, and then we read off the value from down here. 155, we have here 140. So 155 minus 140, you get 15, not so? Now 15, when you divide by 4, what do you get? I think this will be 3 times, and then remainder 3, so 3.75. So the 3.75 is actually going to be, those are the small boxes you are going to move. So 3.75, this is 1, 2, 3. Then this will be 4. So 0.75 is maybe around here. Okay, maybe around there. So I'm going to get my ruler. Okay, we're going to get the ruler here and we draw. So you draw a straight line. When you draw that straight line, 3.75, so it is just below the fourth one. Okay, so that is that. Then after, you take this one down here, and it is in the middle here. Okay, we can actually make this one dotted so that it doesn't interfere with the graph that you drew at first. Usually we draw these lines dotted. Okay, now we can see, by the way, when I was drawing this graph, I left the 0.5s on these numbers to avoid drawing in between these small boxes and what. So it is better you leave the 0.5s there such that you land on these vertical lines straight away. Now here I'm seeing 19.5, but then there are 3.5 small boxes here. Okay, so I'll get 19.5, and each small box here is equivalent to 1 unit. So I'll get 19.5 then plus the 3.5, and that will give me the answer. So this one here is 19.5 then plus the 3.5, which will actually give us 23 centimeters. So that is that. Then part C, calculate an estimate of the mean length of these 250 leaves. Now what we do here, mean, we know that it is equal to summation of f of x out to summation of f. So how do we get the x? X is the mid value. So we have 18 as the first frequency. Then the mid value is 5 plus 9 over 2. Since we don't know the discrete data, like the data points, individual data points, so the x here is going to be the average of those data points in that given group. Okay, then plus the next one is 28, that's the frequency, and then we are moving from 10 to 14, so you add them, you divide by 2. The next one is 16, then 15 plus 19 over 2. The next one is 72 into, this will be 20 plus 24 over 2. We have 48 into 25 plus 29 over 2. And then 24 into 30 plus 34. Actually, it is 39 over 2. Then from there, we divide by the summation of f, which is actually 250. Now, putting everything together here, what do we have? Now, 18 divided by 2, that is 9. So 9 times 5 plus 9, that is a 14. This one gives us 126. So we shall write here 126, then plus. The next one will be 14 times 24. 14 times 24. That one gives us 336. Then the next one, that will be 30, because 60 divided by 2 is 30, then 15 plus 9. Then 1020. The next one, 72 divided by 2, that is 36, then times 44. 36 times 44, that is 1584. Then the next one will be 48 divided by 2, that is 24. Then times 54. 24 times 54, that is 1296. Then the last one is 24 divided by 2, that is 12, then times 69. That is 828. 828, then we divide by 250. 126 plus 336 plus 1020 plus 1584 plus 1296 plus 828, that is 5190. Then we divide it by 250, and then the final answer becomes divide by 250, that is 20.76. This is a terminating decimal. I don't need to round it off to 3 significant figures and then I write 20.8. It's a terminating decimal and it is a small number, so just leave it like that.